Hello viewers, tutorial 13, question 15, also repeated as tutorial 14, question 7. So we're finding the equation of various graphs. The first one we see on the left there, we have a straight line graph. So it has the form y equals mx plus c. It has a vertical intercept, y-intercept of 6, and an x-intercept of 2. So we can say that y equals k times x minus a, where a is your x-intercept, which is in this case 2. So y equals k times x minus 2. Now we also know what the y-intercept is, so we know that when x equals 0, that's the y-intercept, which is 6. Okay, so we have y is 6 equals k times x is 0 minus 2. So therefore we get 6 equals negative 2k, and dividing that by negative 2 tells us that k equals negative 3, and your equation is y equals negative 3 times x minus 2, or if we expand that out, we get negative 3x plus 6. So we do indeed get our y-intercept of 6, c equals 6 as expected. Okay, graph B, and it is a cubic, so it has 3 brackets. So it is y equals k x minus a times x minus b times x minus c, where a, b and c are your 3 x-intercepts. So we have k times x minus negative 1, which is going to be x plus 1. X minus b is x minus 0, which is just x. So we can just call that bracket x. And x minus c is going to be x minus 2, because 2 is your value of c. It is the third intercept. So we have, let's rewrite that, k times x plus 1, x minus 2. Now notice that we've already used your y-intercept because it went through the origin, which means that you've got both an x-intercept and a y-intercept of 0. This means that you've already used this point as one of the x-intercepts, and therefore you cannot use it again as a y-intercept. We must therefore use a different point, and that's going to be, the point we'll use is 1 comma negative 4 to find k. So when x is 1, y equals negative 4. So we get negative 4 equals k times 1 plus 1 times 1 minus 2. So we just substituted y equals negative 4 and x equals 1. So therefore we get negative 4 equals k. So we've got that bracket's 2. This bracket is negative 1. So we've got 1 times 2 times negative 1 is negative 2. And therefore if we divide that by negative 2, we get k equals 2, and your equation is, let's substitute k equals 2 back into that line. So we get y equals 2x times x plus 1 times x minus 2. Okay, so that's the equation of that cubic. Now question C, we have a parabola. So how many brackets should we have for a parabola? We should have 2 brackets, because we have, it's going to be a parabola is a quadratic, so it has the highest power of x squared. Whereas this would have a highest power of x cubed, hence cubic, and 3 brackets. Whereas this one is going to have only 2 brackets, so we have k times x minus a times x minus b. And what are our 2 x-intercepts? Negative 3. So the first bracket is going to be x minus negative 3 is x plus 3, and this is going to be x minus 2. Now we know one other point that it goes through, and we can use our y-intercept here. That's fine because we didn't have a x-intercept of 0, so we can use our y-intercept. So when x equals 0, what's y? Y equals 3. Okay, so 3 equals 3, well k we don't know, times that bracket is going to be x is 0 plus 3 times 0 minus 1. Okay, so therefore 3 equals k times 3 times negative 1, which is negative 3. And if we divide that through by negative 3, we get k equals negative 1. We are expecting a negative there because that is an upside down parabola. So if we substitute that back into this line, we've got y equals k is negative. Don't need to write the 1, but we do need to put in the negative, plus 3 times x minus 1. Okay, so that's the equation of that parabola. Now we have an exponential graph which goes through the points, 2 points, goes through 0, 0.6, and it goes through 1, 3. So an exponential graph, if we recall, has a shape that goes like y equals a e to the kx. So when x equals 0 in this case, y equals 0.6, substitute that in, we get y is 0.6 equals a e to the k times 0, so a e to the 0k. Now, what's that power? Which is a e to the 0, because 0 times k is still 0. E to the 0 is 1, so we get a times 1, which is a. So 0.6 is a, and we have our value of a, so we know so far that y equals 0.6 e to the k times x. Next thing we need to do is find the value of k. Once we've got k, we have our equation. So we have one other point, which is when x equals 1. So when x equals 1, what's y? Y equals 3. So 3 equals 0.6 e to the k times 1, so that power is just k. Okay, so that means we can find k from that equation. First thing to do is to divide by 0.6. So 3 divided by 0.6 is 5 equals e to the k, and then we can find k by taking ln of both sides. So k is going to be ln of 5, and if we calculate that, we should get a value of 1.609. Okay, so we have the value of k, and therefore our equation is y equals 0.6 e to the 1.609 times x. So that's the exponential graph, and then we have a logarithm graph, which is, it's all mirrored compared to what a normal logarithm graph would look like. So we would expect the multiplier of x to be negative, because a normal logarithm graph, if that's your y-axis, it's normally going like that. But this one is on the left, so it is the mirror image, which means your formula for a log graph is a ln of bx, and because it is a mirror image, we expect a negative value of b. So we have one point that it goes through, so we know that when x equals negative 0.5, y equals 0. So it goes through the point negative 0.5 comma 0 there. If we substitute that in, we get 0 equals a times ln of bx is b times negative 0.5, which is negative 0.5 times b. Now we know that a is not going to be 0, otherwise the whole thing would just be a horizontal line on the x-axis. So we can divide both sides by a, and if we divide both sides by a, we get 0 over a, so which is still 0, equals ln of, so 0 equals ln of minus 0.5b, and we can get rid of the ln by taking e to both sides. So e to the 0, which is 1, is, we got rid of the ln by taking e to both sides, so this is going to be negative 0.5 times b. So therefore, if we divide that by negative 0.5, we get b equals negative 2. So it was negative, exactly as we predicted. So y equals, so far we have a ln of b, we now know to be negative 2 times x. And we can then use our other point, which is when x equals negative 4, because it goes through that other point, which is negative 4, y is 2, so we get 2 equals a times ln of negative 2x is negative 2 times negative 4, which is a times ln of that bracket is 8. So therefore, we can say that a is going to be 2 divided by ln of 8, and if we calculate that, we get 0.962, and so we've got the value of a, and the equation we'll put up here is y equals 0.962 times the ln of negative 2x is the equation of that graph. Okay, and one more function that we're going to do, which is this one. This is going to be either a cosine graph or it's going to be a sine graph, because it could be represented as either one, just with having a different value of c. But looking at what you're given some information about your x-intercepts, which is the vertical middle of the graph. So you're given information about the vertical middle as opposed to the maximums and the minimums as far as their horizontal coordinate is concerned. So since we're given that information, these 2 points, as opposed to say a point here and a point here, or a point here and a point here, we'll be treating this as a sine graph. So y equals a times sine of bx plus c. So just to repeat that, if you had information about these points, the x-coordinates of these points, or the x-coordinates of the minima, then it would probably be best to treat it as a cosine graph, but we've got information about the vertical middle, which tells us that we're dealing with sine. So a is the amplitude, which we already can read off the graph. It's from the middle point to the highest point is a difference of 3, or from the lowest point to the middle point, that's also a difference of 3. So we can read that the amplitude is 3. So a equals 3. We can read that off immediately. Now what about b? b is going to be 2 pi over b equals the period. Recognise as well that these 2 points are exactly 1 cycle apart, because this point is going through, is where it goes through the x-axis on the way up, and this point is the next time it goes through the x-axis going up as you're moving left to right. So from here to here is a full cycle. So the difference between these 2 values is going to be your period. So your period is going to be 2.344 minus 0.25, which is going to be 2.094. Okay, so this has got to be equal to 2 pi over b. So therefore b is going to be, rearrange that formula, so we can say b is going to be 2 pi divided by 2.094 0.094, which is 3. Okay, so we've got B equals 3. Now we need to find out the value of C, which is going to be about the sideways shift. So we can see that compared to the normal sine graph, which would be going through the origin, it's been shifted to the right. That tells us that this sign is going to be a minus. If it was shifted to the left, then it would be a plus. So far we have y equals 3 sine of 3x minus something. Okay, so how far is the shift going to be? What's C? So C over B equals the shift, which is going to be 0.25. So therefore C over B we already know to be 3 equals 0.25, and therefore C is going to be 0.25 times 3 to find C, which gives us 0.75. So putting the whole thing together, y equals A is 3, sine of B is 3x. It is a shift to the right, that makes it a minus 0.75. Okay, thanks for watching. Over and out.